Welcome to Chapter 7, where we're going to be talking about titrations. So this will serve as an introduction to titrations and looking specifically at the example of precipitation titrations as a specific type of titration. We'll be looking at other types of titrations throughout the rest of the semester. So at its core, a titration is a way of doing what we call volumetric analysis, meaning that we are analyzing something by measuring volumes. So the metric means measure, and volume here, of course, is that we're measuring volumes. So to do a volumetric analysis, we need a tool that allows us to measure things to a precise variable amount of volume. And our main tool for using that is a burette. You've hopefully by this point in the class have had a chance to use one or see one in use. And a burette is a long cylinder. The stopcock at the end of it comes down to a tip. And then we usually have our thing we're analyzing down here. And actually this will usually be an Erlenmeyer flask and not a beaker. All right, and so what we want to measure is this is a standard inside of the burette, standard solution. This is something we know the concentration of. And our unknown is going to be in the flask down here. That's the thing we want to measure. So for a titration to work, what we need to know is the reaction. So titrations rely on the fact that there's a chemical reaction that happens between our standard and our unknown. And so often this is acid-base reactions or complexation reactions. In this chapter, we'll be looking at precipitation reactions. So our standard and our unknown are two parts of a salt that will form when we combine them together. All right, and so this reaction has some requirements. It needs to be a fast reaction. If this doesn't happen very quickly, it makes it difficult for us to know when we've added enough of our standard solution. So the reaction needs to be fast, needs to have a large equilibrium constant so that products are favored. Products are highly favored. Basically, we want our reaction to quickly go to completion as soon as we're adding our standard into our unknown. All right, and then the last thing, of course, that we'll need to know is what's the stoichiometry of our reaction. So we need to know exactly the reaction that's going to happen in our titration for a titration to be useful. So just as an example of a titration reaction you might see, this is how we standardize hydrochloric acid, is we take HCl, and HCl in this case will be in our burette. We add it to sodium carbonate. That will react, and this is not an equilibrium, this is everything will go to the right, to form CO2 gas, water, and salt. Of course, in its aqueous form. All right, so we know that the stoichiometric ratio here. This is an example where we have a 2 here, and implicitly there's a 1 here. So if we know how much of our standard solution it takes for this reaction to go to completion, we can figure out how many moles we have. If we know the moles of one, we can find the moles of the other. And that's the main goal we have in a titration.